Hi, welcome. We'll discuss Newton's rings experiment today. So Newton has observed Newton's rings, so that's why this is called Newton's rings experiment. So I'll explain the experimental setup briefly, and then we'll know how to find the different parameters in this experiment, like radius of curvature of a plano convex lens, and also the wavelength of light used in this experiment, and we can also find the refractive index of the liquid that can be um, used to find the refractive index. We can keep it in a beaker and then in the setup. So we'll first see the experimental setup. So basically we have a plano convex lens on a plain glass plate. So we know this is a convex shape, and if you take half of it, then one side it is plane and the other side is convex shape. So this is a plane or convex lens. So if there is no medium, and in the room we have air medium, so mu equal to 1 here. So now the light is shine onto this using the uh, convex lens and the plain glass plate. So the plain glass plate will use here, which is kept at 45 degrees angle. So light comes from monochromatic source, which has a wavelength of lambda, and the light is falling on convex lens. So then the light will fall on the 45-degree glass plate. Then it will deviate towards this plano convex lens. So the light now it comes down. So the light, when it falls on this, it reflects and refracts and then reflects. So this reflected light will pass through this and comes out to be here. And this light we can see through a traveling microscope. So this is basically the setup of Newton's rings experiment. So whenever you use white light here, so you will get colored rings with black and white combination rings. But if you use a monochromatic light, then whatever the color you use, suppose you're using yellow color light, sodium vapor lamp, so you will see yellow color. There will be dark in at the center, and then yellow. Then there is a dark, and then yellow. Then there is dark, and then yellow. So that will be your rings. So if you take red now, so the red, then there is now you can take the whiteboard as the dark, and then red ring, then dark red. So we'll get concentric rings which has same center. So the radius of the rings can be taken as, say, this ring, the outermost ring, the radius can be taken as r. Then the diameter is capital D. So this depends on the thickness of the air filling. So let us see how to derive this plano convex lens radius of curvature. So what is happening basically, if you take the same again, so if you take this plain glass plate and plano convex lens, so the light is falling, say, here, and then this is incident light, incident ray, and it reflects from the top and also reflects from the bottom of the plano convex lens and refracts, and then reflects from the top of the glass plate. So this glass plate which reflects, it is reflecting from denser medium, because its glass is a denser medium, and this is air here, so which is rarer medium. So this denser medium ray will have a additional phase change of pi or a path change of lambda by 2. So you can call it as ray 1 or ray 2. So this ray 1 and ray 2 will superimpose, which is interference of light. Due to that interference of light, when there is a condition satisfied for the dark ring, it will form dark ring. When a condition is satisfied for the bright ring, it will form the bright ring. So we'll also see what is the conditions for bright and dark ring. So the condition for bright ring is 2 mu t cos theta dash is equal to n lambda. But since there is an additional phase change here of lambda by 2, so what will happen to this equation is 2 mu t cos theta dash is equal to 2n minus 1 into lambda by 2. So where n is equal to 1, 2, 3, so on. If you take a dark ring, so the dark ring condition is 2 mu t cos theta dash is equal to 2n minus 1 into lambda by 2. So actually this is plus or minus. So if you take plus or minus lambda by 2, then we get dark ring condition as, so 2 mu t cos theta dash is equal to n lambda. So this is the dark ring condition. Since the light is falling normally and then reflecting back, so we can take theta dash, which is the refracted angle is also 0, and then we can take mu value, which is air now, so we can take this as 1. So if you substitute these conditions for dark ring, so we'll get 2t, because mu is 1, so cos theta dash, cos 0 is 1, so you can have this is also 1, so 2t is equal to n lambda. Suppose if you take bright ring, or bright ring, the condition will be, so 2t is equal to 2n minus 1 into lambda. So now in this equation, if you see 2 is a number, n is 1, 2, 3 is a number, wavelength of light that we are using, so we know. So what is unknown is like thickness of air film. So what is T is thickness of air film. So for finding this T value, so let me draw this plano convex lens and explain how to find the thickness of the air film. So we have, if you take a solid sphere and then cut at the bottom, so this sphere has a radius of r, and this will also be r. So this is center C. Let us take this point as D, and this point where it is contacting the plane glass plate, say this is O. Now we are taking a thickness of air film here, so at this point, so this is also T. Let us call this point as P, this point as Q, and this point as N. Now what we need is this T value. In mathematics we have intersecting chords theorem. So what is intersecting chords theorem says is, this Pn into Nq will be equal to On into Nd. So this multiplied will be equal. So Pn, this value is equal to the air film thickness resulting in the formation of this ring. So for this thickness you have one ring, for another thickness you have another ring. So what will be the distance from this center to that thickness will be the radius of the ring. So this Pn is r. Similarly Nq also from here to here is also r. On is thickness T into Nd. See, if you see OD is 2r. So this is OC is r, CD is r, so 2r, and On is T, but we need Nd, so we can remove On. So what is that we have is 2r minus t. So if you multiply this 2rt minus t square, this is r square. Now if you see, the radius of this plane of convex lens usually will be in 100 centimeters, 200 centimeters. So it's a big value compared to the thickness of air film, which is in millimeters, or even maybe very it will be like centimeters, like 1 centimeter. Let us say 1 centimeter or zero point 0.1 centimeter. So very small thickness of air film. Compared to 100, this is very negligible. So the t square is even negligible. So you can discard that. Then you can get to a conclusion that thickness of air film is r square by 2r. So now we know the thickness of air film. So let us continue our discussion from this equation. So now 2t. So for dark ring, so 2t is equal to n lambda. So what is 2t is r square by 2r is equal to n lambda. So 2 gets cancelled, r square is equal to n lambda r. So this is for dark ring. Similarly, you can do for bright ring. For bright ring, we have 2t is equal to 2n minus 1 into lambda by 2. So 2r square by 2r is equal to 2n minus 1 into lambda by 2. So r square is equal to 2n minus 1 into lambda r by 2. Now if you take this equation, we know the relation between diameter and the radius. So diameter is 2 times radius. And what will be diameter square is 4 times radius square. Now what is diameter of nth ring? Suppose we are taking this as nth ring and the other one is mth ring. So diameter of radius square of nth ring will be n lambda r. So diameter square of nth ring will be 4 into r square values. So n lambda r. If you take the other ring, the next ring or any other number m, so this is 4m lambda r. Now if you subtract dn square minus dm square, then you can get n minus m, 4 into n minus m into lambda r. So this is the equation. From this, if the concept is to find the radius of curvature of plane of convex lens, this r, then I can take r is equal to dn square minus dm square by 4 into n minus m into lambda. So if I do this experiment and find out the diameter radius, I can get the diameter. And if I know the diameter of nth ring, mth ring, then number of n, number of p, m. And I am using the monochromatic light. Suppose if I use sodium vapor lamp, I know 5893 Armstrong units is lambda value. So I can substitute and get the radius of plano convex lens, which is very easy. So to do that, similarly, suppose if our this is one part of Newton's rings. Suppose if it is asked to find out the wavelength of light used. So what I can do if they have asked to find wavelength of light used, then simply I can take the same equation. So I can take the same equation there, and then from here I can find out lambda is equal to dn square minus dm square by 4 into n minus m into capital R. So that's very simple. Also we can show this is the number one part of it, and this is number two. Number three part of it is I can show the diameter of the dark ring is directly proportional to square root of natural numbers. So how can I do that? So if you take this equation, so what is the diameter is square root of 4n lambda r. 4 is a number, lambda is the value fixed for one light, radius is also fixed for one plane of convex lens, so it's obviously directly proportional to n. So n is 1, 2, 3. So diameter of the dark ring is directly proportional to square root of natural numbers. Similarly, diameter of the bright ring. So what will be the diameter of the bright ring? So if you take from this equation, if you do the diameter thing, so you'll get diameter square is equal to 4 into 4 r square. So 4 into 2n minus 1 into lambda r by 2. So 2 gets cancelled. So diameter is square root of 2 into 2n minus 1 lambda r. So here diameter is directly proportional to 2n minus 1. So if n is equal to 1, then the diameter will be equal to square root of root 1. If n equal to 2, 4 minus 1 root 3. 3 then 5. So root 7. So you can find diameter of the bright ring is directly proportional to square root of odd numbers. So this is how you can find. And the last one is to find the refractive index mu. Since we have taken 8, so we took mu value 1. Suppose if you take a beaker and put liquid in it. So the liquid has some refractive index. Suppose if you take oil, then it is not equal to 1. So what is happening is it is not equal to 1. So if you derive the whole derivation, then you will get some equation with, say, this same equation. You will get d square is equal to 4n lambda r by mu. So if you do without oil and with oil, you will get the difference. So if you take that into consideration, then you will get dn square minus dm square by dn dash square. You can call this as dn dash square. Similarly, dm dash square. So with liquid, we are representing a dash. So basically, using this equation, you can find refractive index of the liquid that you are using. So these are some of the applications of Newton's rings. So this is the concept of Newton's rings and its applications. Thank you.